Welcome back, students. Let's resume our discussion on limit computation. We went through 0 over 0 type limit, and then we went through infinity over infinity type limits. Now let's talk about one-sided limits, where we have some fractions or some transcendentals or absolute values. All these are case by case, and many a times graphs actually help. So if you have graphing calculator at hand, then that's going to be really helpful. For example, things like this one, if you put into graphing calculator, you're going to see the limiting behavior, whether going up or down, just by looking at the picture. And let's suppose that we don't have the picture, then you have to do something like this. Factor the denominator, and then we don't have canceling out. Now x is going to 3 from negative side, alright? From negative side, alright? So this x minus 3 is going to 0, but it'll stay negative. And the others are positive, so negative, positive, positive of infinity, so we have negative infinity. If this is going to 3 from plus side, everything is positive, and then this 2 is positive, so you're going to get positive infinity. But then again, that's a little bit difficult. Much better way to see it is to rely upon the graph. Draw the graph, and then you can see vertical asymptotes, but x is going to 3 from negative side. Oh, it's left hand side, this one. It's going down, negative infinity. That's the easier way to answer it. So please utilize your graphing calculator. How about this problem? Again, it's going to be better if you graph it, but let's suppose you don't have graphing calculator. In that case, it's kind of like this. X is going to pi over 2 from plus side, and then tangent of pi over 2 from plus side is negative infinity. That's the nature of the tangent function. Even if you do not have graphing calculator with you, you may not be able to graph the exponential tangent of theta, but standard shape of tangent function, you can draw it out of hand, maybe not accurately, so you can see this behavior down here throughout pi over 4 going to negative infinity. So we have e to the negative infinity, which is 0. Yes, you can do it without calculator, but with calculator, of course, you're going to just graph this function directly, and you're going to get your answer as a matter of fact. I'll leave that to you. How about something like this? If you have absolute value function, that too can be answered using the calculator, as a matter of fact, if you have a nice graphing calculator. But if you don't have calculator, then you have to do something special. How to remove absolute value. When x is greater than 0, then absolute value is same as x. X is less than 0, we need extra negative sign. Here x is going to 0 from minus side, we need extra negative sign here. And basically this is a computation here. We need extra negative sign. So minus minus plus, we have 2 over x. And then we have negative infinities. It's going to 0 from minus side, so negative infinity. The other way around, plus side, then we don't have extra negatives, so x over 1 over x over 1, that's just 0, so limit of 0, that's going to be 0. Again, if you graph it, then all problem just disappears. You can clearly see the picture, and I'll leave that to you. And same thing goes this one. Again, if you draw the picture, you can do it. Okay, so much for some quite a bit unimportant topics, but I covered it anyway. Let's talk about the hardest type, infinity minus infinity type limits. Here's an example, going to 0, so this is infinity minus infinity type. How do we handle that? In that case, you just do your usual thing, take common denominator and make it into fraction. Then you're going to end up with 0 over 0 type limit or infinity over infinity type limit. In this case, it's going to be 0 over 0 type limit. Take the common denominator and then do some simplification. We have 0 over 0 type limits right over here. Simplify, cross x out, and you can plug in numbers. So this was one of the easier type. Just take the common denominator and that was it. This one, on the other hand, is in completely different league. How do you handle that? We have square root minus square root. Is there any way to simplify it? When you have square root, think about conjugation. We saw that earlier, right? We saw that in this example. Remember? We multiplied the conjugate to both numerator and denominator and fold it out, and you ended up with square minus square, so that the square root and square cancel each other out. We're going to do the same thing here. We are going to multiply the conjugate to both numerator and denominator, and here we go. The blue part is the conjugate. And what do we have? We have a minus b times a plus b. A minus b times a plus b. So we have a squared minus b squared. Result, square root disappears and we have just plain subtraction. In the end, what do you get? This x squared and that x squared cancel out, and we get negative x there. And then down here we got something like this. This is infinity over infinity type limit with appropriate growth order. Growth order of 1 is here. Growth order of 1, growth order of 1. So removing this unimportant part and removing this unimportant part and that unimportant part, we get this expression, and here is simplification. We end up with negative 1/2 like that. The key computation is this, the conjugate, and that in the end you're going to get infinity over infinity type limits. Okay, have I written this kind of problem in the exam in Calculus 1 level? Okay, I have a confession to make. I've been teaching calculus from 1996, but have I written this level? I haven't, to tell the truth. It does appear in our textbook, but alright, that was my confession. But that doesn't mean it'll never appear. This kind of problem I have looks like I better stop here, and then we're going to talk about continuity in a separate video.